In this video, I think we'll take a look at this Krohn-Hite 4200A. I bought this and I showed it in a previous mail video. Cost me $57 plus $17 shipping. And Krohn-Hite says it's a 10 hertz to 10 megahertz sine wave oscillator. It has two outputs. This is 1 volts with an internal impedance of 600 ohms. This is the output following this attenuation device, and it's supposed to be 50 ohms. You notice these push buttons are calibrated in volts, and adjacent to, say, 10 volts is a plus 20 dB label. That's not plus 20 dBm. And these, according to the instruction manual, these voltages are only accurate if this is open circuit. But it's supposed to be terminated at 50 ohms, which it looks like cuts all these numbers in half. I'm also not sure what this vernier does. It looks like 0 to 10, but with an internal dial of 0 to 3. I would have expected this to be a divider from here to here. It looks like it's all factory except for the fact that somebody has installed a fan. What I'm going to do is hook each one of these outputs to my oscilloscope and turn on both traces. And I'll set the dial, I guess it's already set, we'll set the dial for 50. So that would be 50 hertz, 5,000, or 50,000 hertz, 5 megahertz. This is the dial multiplier. It is IEC connected, so that means it's not in the 70s at least. We'll see if we can find a date code when we open it up. First thing though, let's see if it works. So they've hooked up the coax connectors to the oscilloscope. I'm going to leave the oscilloscope on 1 meg input. If I go to a 50 ohm termination, these numbers get cut in half. So let's power it on. This fan is ridiculous, so I'm going to disconnect the fan. I'll power it on again. So here we have, this is the 1 volt output. And it is 1 volt. However, we're not getting an output from the other side. Doesn't look good. Let me switch inputs just to make sure I'm not misdoing anything. I'm going to take away this one, take this one and put it over. So there we're getting 1 volt. Exactly the same as before, except I've swapped them around. So something's happening between here, which is taken after the oscillator but before the amplifier, and here. So this is not, well, half of this is working. We'll take it apart and see what problems we have. We'll make sure we unplug it first. And then disassembly requires removing the sides first. And then a side comes out. Have to do the other side next. This is a pretty typical Krohn-Hite enclosure from the 80s, 70s. Fan looks nice. Whoever cut the hole did a good job. You can see whoever installed it used locking type nuts. Don't come loose. And it is a 110 volt fan, so getting something quieter is going to be a real issue. Looks like the fan has been taken apart. I don't quite understand that. I guess we can go next to the bottom, it doesn't matter. Now the washers are still on all the screws, that's good. It means nobody took it apart and just slapped it back together. Now I guess this is the top. And we'll look at the bottom. These are capacitors, I guess they're calibration devices. Oh, it says frequency calibration. Why not? So looking at all the soldering, it looks, I don't see any flux marks, which means it hasn't really been screwed with. Or whoever did it took exceptional care. So that's good. There's some big clamp-on thermalloy heat sinks. It's probably the power amplifier. And we'll look at the top. So we have a vernier device. Heat's oiled. These white things are potentiometers. These, which we saw on the side, are variable capacitors. Look at this fellow. See, the end's blown out of this capacitor. I won't even try to measure the value of it, I'll just take it out. Maybe then I'll measure some in-circuit values in ESR. There don't appear to be any integrated circuits. There's two regulators, I'm guessing, or regulation transistors bolted to the back. Here and here. I'm guessing, oh yeah. We have test points for a minus 22 and a plus 22 power supply. Another big heat sink over here. So where did they pick up the 110 volts for the fan? That's this wire coming around here, and they just grabbed onto the switched power here. When I say switched power, this is a 120 240 switch. voltage selector. It looks like one side of the capacitor is here. And the other side is here. Desoldering tool makes it really nice. It's 100 at 25, that should be easy to replace. And I don't know if this is a date code or not, 8401. I did see an 8407 on this transformer. And it's labeled 71 as opposed to, say, C, I guess you can't see that, C117. This is just a 71. I was hoping to track that down in the schematic. I should point out these are dual transistors. I'll get a better shot of them. See this one marked Q103 and Q102? They're actually two, 2092 cases back to back, held together with a piece of spring, probably beryllium copper. So they're butted up against each other. The idea is to make the heat, whatever is varied, whatever characteristic of the transistors varied by heat, they are both affected identically. And Krohn has made use of these. Here's one, well, here's a pair. So they're thermally connected transistors. So we have a section here called an oscillator amplifier, as opposed to an ABC amplifier. And looking at it, we've got these two thermally connected transistors, and this is the capacitor that's bad. C203. So right next to it and connected to the positive side of it is a 620 ohm resistor. Okay? And the 620 ohm resistor is this resistor right here. This line marked 71, the positive symbol up there, that's where I took the capacitor out of. You can see the 203 right there. And 202 is under the label. And those transistors are sitting diagonally here. So I take it that 203 is the top one, or this one, and 202 is this one. I'll test this capacitor I'm going to use as a replacement with this TC1. It measures 100 microfarads and an ESR of 0.3. As long as I'm doing this, I think I'll just take and replace both of these. I don't know whether it's better to leave a good but very old American-made capacitor in, or replace it with the new Chinese El Cheapo. Here's the other capacitor I said I was going to take out and replace. And you can see it's a 99 microfarad with an ESR of 0.48. So this may have not needed replaced.